Hi everyone, welcome back to Pine Hollow Auto Diagnostics. Today we have an old Chevy K3500 four-wheel drive diesel. I've never worked in one of these. This is pre-Duramax, old school, big beast, 160,000 miles. I guess it's in pretty decent shape. Frame looks pretty nice. The owner tells me that it's barely drivable. He starts it up, it revs through the roof, like 2,000 RPM idle. He puts it in gear, it almost wants to do a burnout. The throttle is very touchy, so he said it is not fun to drive. He wants that addressed. What do we have in the in the cab here? We have gas pedals, and we have magic black boxes. Electronic diesel injection. There's another one. There's another one. What are those? It tells me that is the PDM, or the pump driver module. What is the pump driver module? How does it work? I have no idea. We're gonna have to do some serious research on this truck. But for now, let's plug in the old school GM 12-pin connector and the VERIS. Boot that up, look at some live data, see if it sets any codes, run it, see what it does, and then go on all data and read about the system. What controls the throttle? Apparently, it's this throttle pedal is a sensor. For 1995, that's pretty advanced, I guess. So let's gather some data. First, let's take a peek under the hood. 6.5 liter diesel turbo. We have a Napa alternator, and before we get too far, let's just quickly check the engine oil before we start this thing up. Where is the dipstick? Engine oil right here. Yeah, close enough, as long as there's some in it. Looks like black sludge. It's probably normal. Coolant level is fine over there. Plenty of coolant. And I think this black box lives right here. So this looks like the diesel injection pump, and the owner told me that apparently these are failure prone because they live right here and it's like super hot inside the valley. So when he got it, it already had a little pedestal here to relocate that module. So it sits on the pump, but it doesn't, if you take it off the pump, it's not like it's interfacing right there. It's interfacing through the wires. So there's the original plug, and then these pigtails, there's one right here that goes down there. Two different pigtails, and he said that this is the one he just installed. The flying wings of quality, but it is made in the USA. Okay. 1, 2, 3, 4, 5, 6 wires there. There's the other pigtail. So apparently people relocate these under the front bumper to keep them cool. These pump driver modules. That's the information that I have. Let's fire it up. See how it runs. Boot up the VERIS here. Well, let's log in first. Okay, so we have our truck identified correctly. So the VERIS is the only tool that I have that will work on this. That's why it's priceless. Let's see, engine, automatic. Let's turn the key on. Special adapter, yes. It'll start talking to our little module. Ready to start. The glow plug light went out. Let's just see if there's any codes. Current codes, no codes present. History codes. Transmission input speed sensor fault. Pedal position 2, 5 volt reference fault. Okay, so history doesn't mean they're happening right now. Go right into our data. Now the pedal that they put on here is also Napa aftermarket. And he said he tried an OEM from another Chevy diesel and nothing made a difference. So I don't think there's a problem with the pedal, but we can look at the 3 position sensors here and just depress the pedal slowly all the way down. That's floored. See, throttle is 96%, and all the way back up. So that looks fine, but I just want to reinstall one of the original pedals. Boost PSI 14. Coolant 143. Huh. Well, how about that? I don't like this. Coolant sensor. Okay. Air intake, that's 48. You know, that's accurate. It's in the mid 40s right now outside. So I don't like coolant sensor. That's a red flag. TDC offset. Injection timing. So some of these data PIDs I'm not familiar with. We can always look those up. And injection timing degrees 14. Injector close milliseconds. Okay, that's fine. So coolant temp. Let's before we start this thing, let's unplug that. Or should we start it, see how it runs first? Yeah, let's do that. Okay, crank no start. Woo! Okay, not happy. Not happy at all. Look at that, coolant 248. Okay, key on 143. Let's record that data and unplug this coolant temperature sensor. I just want to see what it does if the coolant temp sensor is unplugged. Alright, so we're at 150 degrees right now. I assume this is the sensor. I'm just going to unplug it. -7. Alright. Plug it back in. 152. Let's leave it unplugged. See what happens. -7. I guess you're not supposed to run a diesel below -7 degrees Fahrenheit. Okay, key off, key on. (2,000 RPM). Woo! So it does that. Crazy. The customer did not tell me that it does this. Okay. The next thing I want to do is unplug that Dorman smart box. Now, I looked at some info. We'll look at it in a second. But that module controls basically the amount of fuel. That's how this engine controls its engine speed. There's no throttle body. It's just based on the amount of diesel injected. There's a big solenoid on the front of the pump, so this is the shutoff solenoid, there's another one that you can't see under the intake manifold, and that's what's controlled by this box through, you know, signals from the engine computer. So if you unplug that, that solenoid should stay shut, and we should get a no crank. Let's see. Okay. Interesting. I guess we just plug in one of these boxes and see if it runs. Alright, so I plugged in this guy, and oh, we have a massive leak of some sort coming from the water pump. I don't know. So I plugged in that pigtail into the truck harness. Coolant temp sensor still unplugged. Let's see. Same exact thing. Crazy. We might have to do some research. Alright, so with the third module, it's doing this. It didn't go through the roof. Interesting. Let's try the fourth module. If these are all different, they're all junk, well, I don't know what to do. Module number 3. Jeez. So 3 of the modules do that, and one of them does the low RPM thing. That's crazy. Alright, so I'm going to use the decade box here to dial down this coolant temp. Let's see, if we go up in resistance, it's going to go up. We need to go down, down, or up. So 113, 107. What the heck? How does that make any sense? How did it go from 107 122 to 260? Is it some kind of dual resistor thing? I want to get it down to like 50 degrees. This doesn't make any sense to me. Huh. Alright, I got it. So it has to be like 2 kilo ohms. That's 87 degrees. 84, 82, 64. Let's try 64. We'll leave it at that. Start it up. We can clear the codes out right now. It's fun playing with these old, old vehicles, and the guy's taking it to several shops. He's about 2 hours away, and they're like, take this thing out of here. We don't want to deal with it. Understandably, these would cost the shop a lot of time to do it right, and they probably don't have any of the older guys. They all retired who used to work on these things. So the history codes are still there. No current codes. We're going to need to get the scope out for this, because we know that for some reason that solenoid is being commanded crazy open, and then it's falling on its face. It could be a computer fault, like the ECM, for sure. We'll need to look up some information and then see where we want to attach our scope. But I tried all the modules again, and they are doing exactly the same thing, where it just, you know, goes up to 2,000, it goes woo, spikes through the roof, comes back down, starts bouncing. Yeah, pretty crazy. All right, let's see what this thing does with coolant temp at 64. Not happy. Oh man. Yeah, let's get some wiring diagrams and let's see where to hook up our oscilloscope. So with the truck running like this, no code's present. That's how dumb these old systems are. Obviously there's a problem. So I put the original accelerator pedal back on. So off the accelerator, we're here, on the accelerator. It revs a little bit more. If we look at the data, these fuel related see that fuel rate? Boost PSI, that's almost not changing. It goes up a little bit. Let's put it in gear. Blah, 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 blah. Oh yeah, fucking Bronco. So it's trying, but something's really wrong. So when you first start it up, it's at 2,000 RPM. Why does fuel rate say 0? Now I'm going to touch the throttle. And now it's going to go into that funk where let's try again. 2,000 RPM. And keep in mind, desired idle is 844. We're at 2,000. Exactly 2,000. Touch the throttle. Wow. Wow. So definitely an electrical problem. I'm 100% sure of that. It's not like the injection pump solenoid sticking and da-da-da-da-da. We gotta get a scope on this thing. Definitely don't want to blow up the engine and redline it. See what the computer's commanding this pump driver module to do. Alright, did some research online. First, let's start with the easy stuff. Coolant temp sensor. There is a chart of temperature versus resistance. So right now I actually measured the sensor, 667 ohms, which should be about 140 degrees Fahrenheit. That's reasonable. We ran the truck for a little bit. Now let's plug in the sensor and see what scan data reads. It should be 140. Remember, we started at 150, which doesn't make any sense at all. Okay, we can use the decade box to see if the PCM is basically if the table inside the PCM is reading these correctly. Alright, so I plugged in the sensor. We're reading 132 degrees Fahrenheit. So that actually seems normal now. That means our coolant temp sensor was misreporting when it was cold. Okay, very interesting. So it's 70 degrees when it's, you know, cooler, or even when we start at about 50. It should be about 6,000 ohms. It was way off. It was reading 150, like 500 ohms. So the coolant temp sensor is definitely bad, but the computer is reporting correctly at the moment. Now let's look at that fuel injection system. Alright, so I have the diagram printed out for this fuel solenoid driver, and this is the pump. So this is the PCM, and well, you can see that there are several components controlled by the PCM, and the fuel solenoid driver is what controls this fuel solenoid. That's basically your throttle control. So we have this fuel inject control, 2 pins go into 1 pin, and then fuel inject signal, closure, ground. We don't know what any of these are, but this is where we're going to do our testing. If we read the description and operation, so here's what the pump looks like. It has 8 high pressure outlets, and pin item 7 here is the fuel solenoid. So that is what's controlled by the fuel solenoid driver. Fuel inject signal, the fuel injector driver, that's the PDM, receives an inject command signal from the PCM and provides a current regulated output to the fuel solenoid that controls injection. It also returns an injection pulse back to the PCM to inform it when the fuel solenoid has actually seated. Okay, very interesting. So on this thing, this is our magic box. Number 1 is fuel solenoid driver, and it drives the fuel solenoid. So the two wires go from here to here, and on our diagram, these are the 2 wires. So there is a ground. We should check that, obviously. Basically disconnect this connector, and it's easy to do because we have like 4 spare driver boxes. Make sure we have a good power with the key on pin D, pink wire, and then a good ground on pin F, that's the black wire, through the solenoid. Okay, then we're going to put the scope on here, and I want to measure all the other, the other 4 wires, the interesting ones. So channel 1, pin A, is going to be our fuel inject control from the ECM. That's telling the fuel solenoid driver how much fuel we need. Channel 2B will be the output to this actual solenoid, the voltage driving the solenoid. Okay. Channel 3, this closure ground, again, we don't know exactly what it does. I couldn't find it in the description, but we can see what it does with the scope. And then channel 4 is going to be this fuel inject signal. I'm guessing that's like a feedback. So let's set up those 4 channels and fire this thing up. Alright, let's do the easy checks first with a test light from battery positive. Pin F on the truck side connector should light up the test light. That should be a good ground. Now the sunshine might be a little bright, but you can see the test light light up right there. So that's good. Now let's check test light to battery ground. Let's check the ignition feed on pin D. Okay, with the key on, we should have power on pin D, and I expect to have power since, the truck does start and run, and you can see that the test light does light up there. So now let's hook up the scope to the other 4 pins and run it with one of these modules. Alright, we got 4 channels on the PicoScope. So pins A, B, C, and E. We measured, we verified powers and grounds on pin D and F, so that's fine. We got 4 more pins, and we're going to use this one, the supposedly OEM module. They all perform the same, but giving it the best chance that it has. So let's fire up the PicoScope and see what happens. Alright, we got 4 channels. Key on. Okay, so it's actually idling. I'm going to give it just a little bit of gas here. revs up to 2,000. As soon as I touch the accelerator, and then it just completely redlines. Okay. Alright, let's take a look at this data. Channel 1 is PCM to PDM control. Okay? And then the PDM fires this coil. Now I had to reduce the scale by a lot so it wouldn't take up the entire screen, because it looks like this. There's voltage spikes on it, but it does, fire the coil and hold it. So this is one event, and this glare is going to be ridiculous. I might have to review this footage somewhere else. Alright, let's review the data. Got a little glare shield, and well, first we can say that the modules are doing what they should. So the computer is commanding the module on the blue channel, so there's a pulse width, and then the module energizes the injector and holds it at a certain voltage until it's commanded to close, and we see a nice spike. That means the actual whatever fuel solenoid moved, and we have this feedback pulse. So everything is there. Now, how, is this pulse width modulated? Is this duty cycle controlled? What's the strategy? We can look at, the low and the high RPM zones. Here's when it really went out of control to like 4,000 RPM. And you can see the feedback just started dropping out, because that's just went nuts. But like this pulse width, that's the injector on time, or the fuel solenoid on time. Not injector, just the fuel solenoid. The injectors are passive. They're just, nozzles. So it's like 3 milliseconds. Okay? And then we have this confirmation pulse. So I think this injector close data PID is what is supposed to report that's this right here. See, 3 milliseconds. In the beginning, when we first started it up, right here when it was still running at like 1,000 RPM, see, delta there is 5 milliseconds. Okay, well, is it normal? Is it abnormal? We can measure the hertz. I don't know how many pulses it does per engine revolution. It might be a good idea to grab the crankshaft position sensor waveform just to see the RPMs and correlate them to this scope capture. But from all this data, what are the possibilities here? Bad ECM, that's just making this fuel solenoid open way too much, or a bad module, which very unlikely. We tried 4 of them, they behave the same, and according to the scope, the module is doing what it should, and the solenoid is also doing what it should. It's following the module every time it pulses it. It's like buzzing, opening and closing just fine. But as soon as you touch that throttle, the ECM, something commands it to go crazy, and just the engine goes through the roof, the RPMs. So it's looking like an engine computer problem. Now I want to correlate this to scan data to see what the heck is out of whack. We have a few data PIDs, injector, close time, or I'm not too worried about the injector timing. There's that stepper motor that controls the timing of the injectors. We're worried about fuel volume here. That's the main throttle control, and that's what's acting up. So let's do a few more experiments to prove that out. Alright, so how do we tell if the PCM is commanding this fuel solenoid driver to ramp up the RPMs. This is where a 4-channel scope with math channels like the PICO is invaluable. Let me show you what I did here. So I moved channel 3 from that ground wire, which wasn't very useful, the ground is fine, to the crankshaft position sensor signal, this yellow wire. So that would be yellow PD13. So I want to see the RPMs and the command of the solenoid, and for that we need math channels. So here's a crank signal, this green channel right here. And using the time cursors, I figured out that every 4 pulses, 1, 2, 3, 4, is 1 crankshaft revolution. And you see right here, we're maxing out at 4,000 RPM. It actually shows that this is a 4x signal, so that's pretty cool. The diagram is accurate. So the black trace here, if you go to Tools, Math Channels, this channel right here, 15 times frequency of C, because frequency is in hertz, so that's cycles per second. But we want RPM, right? Revolutions per minute. So you need to multiply the frequency by 60, but we have 4 pulses per revolution. So you divide that by 4, so basically it's 15 times the hertz is the RPM. Okay, that's my black channel right here. And if you move this cursor around, so for example, right there, we're at 1.8 kilohertz, or in my case, it's 1,800 RPM. That's the way I set up that scale. So you'll have to experiment on your own and follow those steps to set up an appropriate scale. So let's move to where I started the truck right here, and it actually kind of idled, lumpy, but idled at about 650 hertz or 650 RPM. Okay, so that's fine. And then I touched the throttle, and the RPMs went up to that 1800 mark where it likes to hang out. Then it did a couple throttle blips, and the RPMs jumped up really fast and came back down to 2000. And then here it basically revved through the roof. There was a little fuel cut, and then it came back to 2000, and then back down to 650. I put it in gear, then shut it off. Now, what is the PDM command? That's this blue trace, and for the blue trace, I want to graph another math channel, which is the duty cycle of the blue trace. So, for example, right here, and it's really nice that PICO shows you, we're at 35% duty cycle. And if you want to confirm that, just zoom in where your cursor is, and yeah, that's about 35% on time. Very cool. So in math channels, what I'm talking about is duty of A. Okay, and if you want to change that, you just click Edit, and right here you can select frequency, duty cycle, anything, and then channels A, B, C, and D. So this is, the orange channel is coming from the blue, and the black channel is coming from the green. That's the RPM. So I want to see what's the command, and then what are the RPMs doing based on that command. So when it revved up really fast, look what happened to our command. It went up to a maximum of 64%. See that on time? 64%. And it happened extremely quickly. This ramp up right here, from 35 to 64%, right there, I touched the throttle and went really high duty cycle, and then drop back down, the RPMs came down to 2,000. Okay, let's go back to where it started. So let's look at the duty cycle right here. About 30%. And then it bumped up to 36%, and the engine speed went up to 1800 RPM from 700. But during these events right here, where it just ramped it up really quickly, the computer is doing that. But why isn't it reducing this duty cycle down to where the desired idle is? Here it hit the rev limiter, so it cut the fuel completely. So, the RPMs eventually did fall. So is the PCM commanding the wrong thing? That's my question. Because right now, we're deciding, is it a bad PCM? Is it commanding the wrong thing? Or is it a failing injection pump? Like mechanically maybe, the solenoid's sticking or something. Right now, this data is telling me that the PCM is in control, but it's doing weird things. For some reason, why would the RPMs just stick at 2,000? It's not like a broken spring. Then, of that solenoid, it would be a lot more erratic. This is kind of repeatable. And you touch the throttle, it goes, way through the roof. The duty cycle command increases drastically. You can't gradually increase the throttle. So let me save this. We'll do another running capture with the throttle, control. And then, are we calling a PCM? Maybe it's a bad prom chip in there. This is old school stuff. So there's a couple more things left to do.